Hi guys, you are watching channel Mr. Electron, and this what you see is a Vanco KBPC 3510 bridge rectifier single phase with a maximum current rating of up to 35 amperes. So today in this video I'm going to modify it into a 3-phase rectifier for wind turbine generators. So these what you see are diodes, okay, and each diode has a rating of around 6 amperes. So I'm going to use these to convert this single phase into a 3-phase rectifier and with a current rating of up to 18 amperes. So guys, the first step is to make 2 sets of 3 diodes, okay, 3 on this side and 3 on this side. Let's keep these on one side. Now this gray side that you see, this indicates the negative. So what I'm going to do is connect all the negative sides of these 3 diodes together, okay. So let's do that. So guys, the soldering part of the first set has been completed. All the negatives on one side and all the positives on one side, okay. Same for this set, all the negatives and all the positives. Now guys, both the diode sets have been completed, okay. This is the negative side for all the 3 diodes and same for this one. So let's talk about this set, okay. So the negative side of this set will be connected to the positive stated terminal of this rectifier, okay. Okay, let's move on to the next one. Now guys, in a rectifier, if this side is positive, then its diagonal opposite is the negative, okay. So this one is the negative terminal of this bridge rectifier. So to the negative terminal, the positive side of the diode will be connected, which is this side, okay. Gray one is always negative, so the other side automatically becomes positive, okay. So let's do that. Yeah, positive terminal of the bridge rectifier has also been connected. Now this one and the diagonal opposite, this one, these two are the AC terminals. So we will connect the wires afterwards, but this one to which the diode has been connected and this one to which the other set of the diodes has been connected, these two are the plus and minus output terminals for the 3-phase DC rectifier. And since the output current is high, so I'm going to connect the wire of similar rating, okay, to this one and this one. So let's do that. So guys, here as you can see that I've connected the 2 wires to the positive and the negative respectively, and now comes the time for the 3-phase AC terminal connection. The first one is going to be this one at which the diodes meet, okay, this point. This will be connected first, and to this terminal I'm going to connect the red wire. So guys, now comes the final connection. Okay, let's turn this wire like this. Like this side is going to be the 3-phase side and this side is going to be the DC high current output side. So 2 more wires are needed, which I'm going to use these. So let's take blue one. Doesn't matter which color wire you take, all of them are AC. So you see this terminal, okay, here as I showed you, it's showing the AC sign. So this will be connected over here like this, done. And this terminal black, this will be connected to the last terminal that is left out, and move it like this. Same for this one. And we have our 400 volts and up to 18 amps 3-phase full bridge rectifier. So guys, the part 1 was about the construction of this 3-phase rectifier, and this part, the second part, is going to be about its testing with the help of this 3-phase brushless generator, which actually is a motor, but I'm going to use it as a generator. So guys, for the connection of the rectifier to the generator is simple. This and this. These three wires are the three-phase wires which will be connected to the three terminals of the three-phase generator. Okay, so let's do that. Done. Second also done. And yeah, so all the three wires from the bridge rectifier have been connected to the alternator. After which comes your multimeter. Now to the final DC output terminals from the rectifier, the multimeter pins will be connected. And first what we are doing is the voltage measurement. So giving it the simple hand rotation, you see 2 volts and no locking at all because there is no load, it's only voltage measurement. Let's see the maximum I can do with hand rotation. 5 volts. I think there were 5.1. So 5.1 was the max I could do. Let's move on to the rope testing. Keep watching the display screen. Okay, go. So as you saw, it was 24 volts DC maximum, no short circuit, perfect. Moving on to the load testing. Let's remove the terminals. Now here what we have is a 55 watts car headlamp bulb that I am connecting to the rectifier output terminals. Okay. So you saw that it was glowing, but obviously it was a little hard for me to rotate the shaft when it was under load. Okay, that was pretty bright. Let's turn off the lights and give it one more chance. I have turned off the lab lights completely and now only the camera lights are on. Okay, that was pretty awesome. Now guys, I have another better replacement for this generator. Okay, this is not actually a generator, it is a BLDC motor that acts like a generator when rotated, which is this one, a real wind turbine alternator, 400 watts. So let's do the connections, and obviously it is going to generate more power at the same input load because the difference between a wind turbine generator and a BLDC motor is the matching between the number of stator and rotor poles. So guys, I have done a little change. I have placed the alternator on a vise and the three wires have been connected to the three-phase bridge rectifier with output connected to the 12 volts bulb. Okay, so let's get on with the test. Okay, first I'm going to start easy. You see it is glowing pretty good. Now I'm going to put more power to the shaft and I've also turned off the lights. And yes, increased the length of the rope because the pulley is bigger. Okay, go. Wow. You see that at the same power, I would say that it was a little bit easier than before. Once again, see.